Hi, it's Frank Hoos from minilathe.com. I have a new mill here ready for a review, and it's referred to as the SX2.7, manufactured by SIEG. Those of you who are familiar with my website, minilathe.com and minimill.com, know that I periodically do reviews, a lot of them on the SIEG product line. And when I first started doing that back around 1999, SIEG really had just one mill product, I think, which was the X2 mini mill. And in the years since then, they've developed a fairly extensive product line targeted at the home shop machinist and also light industrial use. But I would say their primary users are home hobbyists like myself. Anyway, there's now the so-called nano mill, the X0 mill, X1 mill, and some variations on that, such as the SX1, the SX1P, then there's the X2 series, and there's several variations of those on up through the X3 and SX3, and on the next page, which I don't have here, the X4 series. So they get larger and more capable as you go up the model line, and within each product series, such as SX2, there are variations. So within the X2 line, there's the X2 mini mill, the X2L, which has an extra long table, the X2P, not sure what its features are, but some of them have the so-called classic style DC motor. Mills that begin with the S have the more advanced and capable brushless DC motor, which has quite a lot of torque and is completely sealed, so it offers more power and perhaps better reliability, although I've never really had a problem with the older style. But anyway, this one is a little bit bigger than the X2 mini mill and a little bit smaller than the X3 series, so that's where the 2.7 designation comes from. So it looks like a good size for the home shop machinist who's looking for something a little bigger and more capable than the traditional mini mills that many of you out there probably already have. Before we get started with the review, I wanted to mention that I have the mill mounted on a hydraulic table from Harbor Freight, and I use this so that I can adjust the height of the mill or the lathe or whatever it is I happen to be reviewing to a convenient working height. But the table does have a little bit of wobble to it, so if any time during the video you notice some movement, that's why. I would not recommend this as a normal operating setup. In actual use, you should have your mill firmly bolted to a bench top or perhaps to a large broad base so that there's no opportunity for it to tip or move around while you're working with it. So that's just a safety tip. I wanted you to be aware of that, and it's a good idea to always keep safety foremost in mind when you're working with these types of machine tools. If you aren't familiar with milling machine structure and use, you might want to first take a look at my videos on drilling on the mini mill and introduction to the mini mill, which will give you a good idea of how mills are set up and used. But basically it's somewhat similar to a heavy-duty drill press, except that unlike a drill press, a mill is designed to be able to cut side to side, and you can make items similar to these where metal is removed by making cuts through the surface of a solid block of material, in this case aluminum. A milling machine in some ways is like a very heavy-duty drill press. It's got a much sturdier frame than a typical drill press, and the reason for that is that while a drill press is designed for drilling holes like you might make in a plate like this, a milling machine also can cut side to side and front to back, so you can make much more complex shapes like this one here, or even this one, which has a curved face on one side and a flat face on the other side. So the milling machine gives you a lot more versatility and capability to make parts and objects that you can't make on a drill press and you can't make easily on a lathe, because the lathe fundamentally makes things that have a circular cross-section in most cases. So a lathe together with a milling machine gives you the capability to make all sorts of parts in your shop, but it doesn't completely displace the need for a drill press in some cases. In a lot of shops you might be able to get by without a drill press, if you have a good sized mill like this, it will take the place of a medium-sized benchtop drill press. In order to make the side-to-side cuts that are made on the mill, you use a cutting tool like this, which is referred to as an end mill. And as you can see, it has a flat end, unlike a twist drill. So it can cut a flat surface on the top of a piece of metal, or it can cut a notch or a groove. Now the end mill typically is held in some sort of a holder like this one, which is called an end mill holder, or sometimes called an end mill adapter. And the end mill itself goes up into place here and is locked in place with a set screw. Then the whole adapter goes up into the mill spindle. So I'm going to remove the drill chuck that comes with the mill, and I'm going to install this adapter with an end mill so you can see how that's done. There's a kit of tools that comes with the mill, and included in that kit is this tool here, which is used to loosen or tighten the drawbar. The drawbar is a long bolt that extends all the way through the spindle, which is the rotating part that holds the chuck. And as you can probably see, as I move this wrench up here, I'm turning the chuck down below. Now this is a specialized tool that engages with two holes in the bottom of the spindle, and is used to hold the spindle so that it doesn't rotate, so that I can loosen the drawbar. So once I've got that engaged, I can now spin the drawbar around. And I now need to tap gently on this wrench in order to break the tool holder free from the taper. And as you probably saw, that dropped down when I gave it a very gentle tap with the wrench. Now I can spin this around some more and drop the chuck completely out. So typically tools on a mill like this are mounted on what is called an R8 arbor. R8 is just an industry standard used for this type of holder. And there are other types, but for milling machines, R8 is the most commonly used. This drill chuck comes standard with the mill, and it's a reasonably good drill chuck for a low-cost machine tool. But you also need some end mill holders like this one, and they come in various sizes with different diameter holes in them. But all of the shanks have the same R8 standard adapter, and it has a groove in it that mates with a pin inside the spindle. So you have to push that up into the spindle. As you rotate it around, you can feel when it engages with the locking pin. And the pin applies torque in this groove to prevent the adapter from spinning. But most of the force between the spindle and the adapter actually comes from the taper itself, as opposed to the groove. So now that I have that in place, I'm tightening the drawbar. Then I want to use this wrench here to get a good final tightening on that. Now with that adapter in place, I can mount my end mill, and I need a hex wrench to tighten that up, and I'll find that. As an alternative to using an end mill holder like this to hold your end mills, you can use a collet, an R8 shank collet, and you can buy these collets in sets of 6 like this. They have hole sizes ranging from 1/8 up to 3/4 of an inch, which will accommodate most of the shank sizes for end mills that you typically use on a mill of this size. So they're a good alternative to the end mill holders for 2 reasons. One is they're generally less expensive, maybe half as much to buy a set of these as to buy a similar set of the end mill holders. But also they have a potential advantage in that the end mill holders extend out from the spindle by 1 inch to as much as 2 inches, depending on the size of the holder, which takes up space between the spindle and the vise, which sometimes can be pretty limited in any case. So by using a collet instead, the collet fits right up in there and doesn't extend hardly at all from the bottom of the spindle, and so you gain an extra inch or more, maybe as much as 2 inches of extra space between the spindle and the vise. So you put your collet up in there, then you put your end mill in place, and use the drawbar wrench to tighten it up, and then this little spindle wrench to give it a final snug up here. It sometimes can be tricky to get those holes to engage or to find them. There we go. And you don't need to tighten it up really tight, and in fact you want to avoid over tightening it, which could make it difficult to remove the end mill later. When you're using a collet to hold your end mill, you have to be careful when it comes time to remove the end mill, because once you loosen up the collet, the end mill will drop straight out, and if you aren't prepared for it, it could fall down against the vise or the table and possibly chip the teeth on the end of the end mill and thereby ruining your end mill, or it might put a gouge in your workpiece and cause a problem that way. It could also potentially hit you on the hand and put a gouge in your hand. So when you're ready to remove the end mill, take a rag and just hold it under here gently as you loosen the drawbar so that you can catch the end mill as it starts to work loose. Now sometimes it will just stay in there because the taper is still holding it. The taper is holding onto the collet. In that case, you tap gently on the wrench and that will loosen it up so that it drops out. But other times it will just come loose on its own and drop out as soon as you turn the wrench up there on the drawbar.